Okay, let's look at the classwork for 713 when we're talking about more applications of exponential growth. So here, we're saving for college. Suppose you have $1,000 to invest and you know of two investment options. You can invest in bonds, which pay 8% simple interest, or put the money in a credit union account, which pays 8% compound interest. Will the option you choose make a difference in the amount of money? Examine the situations below. So first, if you have bonds with simple interest, you'd put in $1,000 and then it's 8% per year. So if you were in there for 1 year, it'd be 1,080, 2 years, 1,160, blah, 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 blah. With year 4 being 1,320. The formula for simple interest is I equals PRT. So at least that's the one that I use for it. And so P is the principal, so how much money are you putting in? R is the rate, and T is the time that you will be investing that money. So basically what's happening is it's adding the same each year. By what percent did your balance increase at the end of the 4th year? So end of the 4th year, you had 1,320. So basically you want to know what percent of that, or the percent of increase. So what percent of 1,000 gives you 1,320? Well, you would divide both sides by 1,000, you'd get 1.32. Remember, the 100% is how much you were already paying, or how much you already had, that's the $1,000. So it increased by 32%. If you're doing compound interest, then it's compound. This one's compounded once a year, and so it's growing. And so the difference is when you you put in the same amount, and then after 1 year you got your 8% interest. But look at year 2, you have more money in there on year 2. And the reason why is when it's compounded interest, basically you're getting interest on your interest. So here it was just 8% times the number of years. Here it's like this one increased 8%, this one increased 8%, this one increased 8%. So you're getting interest on the interest that you had earned previously. So yeah, you get interest on your interest. So if you were to write this as an expression, your original amount was 1,000, and then your multiplier is, since it's increasing 8%, then the 100% is the 1,000, so it'd be 108%, or 1.08. Says, what will be the balance of the credit union account on the 4th year, and by what percent would this account balance increase at 4 years, and show how you know. Well, one way you could do it is you could take your year 3 and take it times 1.08. When you do that, it'll tell you how much is in there on the 4th year, which is 1,360 with 49 cents. So then what percent is that of what you started with? Well, 1,360.49 divided by 1,000 gives you 1.36. Again, the 1 is the 1,000, so it increased the 36%. So on the simple interest, it was a 32% increase in the 4 years, and in compound interest, it was 36. So which type of account would you want? The credit union, because it's going to grow more quickly. Then on the back, these are step functions, and so I actually I did this wrong, so I'm just going to kind of explain to you what they are. It says, assume that the interest is added at the beginning of each year. Make one graph that shows how each type of investment, simple and compound, start with 1,000 and grow over 8 years. So what this is saying is you put in 1,000, you have $1,000 until your first year is over. Then they put the interest in. So then it goes up $80, and then you have the same amount for the whole year. Then it goes up $80, same amount, up. And so this is called a step function, and it's not a continuous function like we're used to, because on day 1 through day 364, you have $1,000 in your account, so it's not going to look like it's increasing completely. We are not going to spend a ton of time on step functions in Algebra 1, but I did at least I wanted you to at least see one. But what you'll notice here, and my graph is horrible, but as the years go on, you'll notice that there's a bigger and bigger separation between the two, because on the compound interest, you just continue to make more money. And so even if it's compounded once a year, you start here, it increased 80, and from there you take your interest. So now you have 1,080 times that by 1.08. So it's pretty close to what that one was. This one's pretty close. But as the years go by, if we would have continued to go, you would see that they would separate a lot more. So basically, down here it says, in the previous chapter, you've used models as an estimate of real behavior, and we've created linear models for scattered data, given you a mathematical way to describe the data and make predictions. Simple and compound interest are both step functions because, so again, continuous would be the one that has a straight line. These step up. Writing equations for step functions can be very complicated. However, we can model the step functions with other equations that we're already familiar with. And that's what we're doing here. So you could just model your linear equation and your exponential equation, and you can still use that to have a good idea of what the answer should be. And so you begin at $1,000 each time. And so when you're looking at your linear function, you begin with 1,000, and it's increasing $80 every year because that's 8% of 1,000. On the exponential, your original amount is 1,000, and your multiplier is 1.08. So we can check our equations; they're the same. But I do want to go through this. It says use your model to predict how much your original $1,000 investment would have at the end of 20 years. So I want to show you how to type this in your calculator because it would take forever for you to continue to create a table. So you would do, if you have one of these calculators, you can go ahead and put 1,000 times 1.08, put that in parentheses, and then the caret button is the exponent, and you would type in 20. And that would tell you at the end of the 20 years, you have $4,660.96. Now, if you're doing this like on your phone calculator, which I can't really show you a video of that because I'm using my phone, you would type it in like one step at a time. So you would first do this part, and this, instead of it being a caret on your phone, it's x to the y power that you would hit. And then you'd hit equals, and then once you have that, then you would take it times your original number, and you get the same answer. So that's how you can use a calculator instead of having to continue to do this for 20 years straight. So what makes using these models, what happens is it can help you represent the real behavior more quickly, and so you get you can use calculations instead of having to continue the step model. So there is video 1. Tune in for video 2 next.